Right now, somewhere on Earth, a little blue dot is glowing on a phone and it knows exactly where that person is standing. Not close, exactly. The big question is how. The answer is flying over your head this very second. 20,000 kilometers up, a fleet of satellites is racing around the planet faster than 14,000 kilometers an hour. Here's our plan. We'll go one step at a time, and by the end you'll know exactly how your phone always knows where you are. GPS is really two things working together. The first part is a team of satellites up in space. All they do is tell you where you are and what time it is. The second part is the map app on your phone, like Google Maps. It takes your location, draws the roads around you, and lights up the best way to go. Here's a secret. Your phone only listens to the satellites. It never talks back. The satellites don't even know you are there, they just call out like a radio for everyone. Every place needs an address. GPS gives the whole Earth an address made of just two numbers. Let's start small with your bedroom. You measure two things, how far across the floor and how far up the floor. About 6.2 steps across and 3.1 steps up. Two numbers point to one exact spot. The whole Earth works the same way. It's wrapped in invisible lines. The lines going across are called latitude. The lines going up and down are called longitude. Latitude tells you how far north or south you are. The middle line, the equator, is 0. Longitude tells you how far east or west, counting from a line called the prime meridian. Let's find a real place, the city of New York. Slide across to its longitude, then up to its latitude, and the two lines cross right on the city. There it is, written as two numbers, about 41 degrees north and 74 degrees west. Tap any spot on the map, and it reads those numbers right off the grid. Here's the cool part. You send those two numbers to a friend. Their map reads the latitude and longitude and drops a pin on the very same spot, so now they know exactly where you are. Each satellite shouts out a tiny message. Here is where I am, and here is the exact time I sent this. Your phone checks how long the message took to arrive. Light is super fast, so the trip is tiny, but the phone can measure it. Then it uses one simple rule. Distance equals speed times time. If you know how fast and how long, you know how far. Knowing the distance to one satellite isn't enough. It only tells you you're somewhere on a big circle around it. Add a second satellite and the two circles cross at just two spots. Getting closer. Add a third satellite and only one spot fits all three. That spot is you. 3 circles meeting, that's how it works. In real life we use a fourth satellite too. Why? Because we are looking for 4 things, so we need 4 helpers. And the amazing part, that fourth satellite even fixes your phone's clock, making it as perfect as the clocks up in space for free. The clocks are the secret of GPS, but space plays a funny trick on time. A brilliant scientist named Albert Einstein figured it out. Trick 1, when you zoom very fast, your clock ticks a tiny bit slower. The satellites zoom fast, so their clocks slow down a little, about 7 millionths of a second each day. Trick 2, way up high where Earth pulls a little less, clocks tick a bit faster. That's even stronger, about 45 millionths of a second each day. Put both together, and the space clocks run about 38 millionths of a second fast every day. That sounds tiny, but a tiny time means a big distance. If nobody fixed it, your map would be wrong by about 10 kilometers a day. You could end up in the wrong town. So engineers set the clocks just right before launch, using Einstein's idea. That's why your blue dot lands exactly where it should, down to a few meters. Real satellites are far away, so they can't reach indoors. So let's build our own tiny GPS for one big room, like a sports hall. First, we put 3 little gadgets in the corners. They're like our satellites. And here you are, standing on the floor. Each gadget measures how far away you are. 1 gadget says you're somewhere on a curve. 2 gadgets and we're down to 2 spots. Add the third gadget, and all 3 curves meet at one spot. We found you inside the room. And just like real GPS, we can write it as 2 numbers, how far across and how far up the floor. That's indoor GPS. Real GPS does exactly this, just with satellites instead of corner gadgets and the whole planet instead of your room. Same trick, bigger space. Now your phone knows where you are. But how does it choose the best way to get somewhere, say, across a busy market full of people? Look at all those little streets and all those people. You want to get from this corner all the way to that stall. Let's zoom right in. To your phone, this market is just a web of dots and lines. Every corner is a dot, and every little street is a line joining two dots. Every street has a cost, how long it takes to walk. Your phone spreads out from you, checking paths, looking for the smallest total cost. And out pops the winner, the quickest path through the streets. Off you go, weaving past the crowd. Zoom back out, and that's your route across the whole market, found in the blink of an eye. And if you take a wrong turn, no problem. Your phone notices at once and draws a fresh route from wherever you are. That's called rerouting. Have you ever sat in a car that just won't move with cars stuck all around? That's a traffic jam. Let's watch one form. Here come the cars, red, blue, yellow, all in neat lines. At first everyone rolls along nicely, leaving safe gaps. But up ahead the road gets crowded. The front cars slow, then stop, and everyone bunches up. Your map paints this part bright red. How does it know? Every phone in those cars is sharing how fast it's moving. Lots of phones barely moving means a jam, so the map warns everyone else. Last question. What about places with no real roads, a forest path or a little dirt track? How does the map ever learn those? A car can't help here. It drives up to the edge of the trees and stops. No road means no car. Only people on foot go further. Simple, people walk it with their phones in their pockets. GPS quietly follows each phone, tracing the exact way they go. When thousands of people trace the same line, a clear path appears, just like footprints worn into the grass. The map draws it as a brand new trail. Add in photos from the sky and from passing cars, and the map keeps growing every single day, roads, tracks, and tiny trails, all kept fresh. Let's remember the whole story. Satellites in space call out where they are and the exact time. Your phone listens, measures the distances, and uses 4 satellites to find your 2 numbers with Einstein's clock trick to keep it perfect. Then the map app picks your best road, dodges traffic jams, and even knows the little trails. All of that just so a tiny blue dot can say, "You are here." So next time a phone says turn left, you'll know the amazing team of satellites, clocks, and brilliant math working together. Thanks for watching. Now you know how it really works.